Hello everyone, and thank you for joining this session. My name is Abigail, and today I'll be sharing about how you can maximize eco-efficiency with MSK solutions. During this presentation, I'll introduce MSK and explain how our technologies support process efficiency in both injection molding and thermoplastic recycling. At MSK, our contribution to green molding is focused on practical improvements that manufacturers can measure every day, such as reducing raw material waste, improving production yield, and maintaining stable product quality throughout the process. So to start off, I would like to share more about who we are. Our roots go back to 1934 in Osaka, Japan, where Meisei Kinzoku was founded with one specific mission: to improve the process efficiency of plastic injection molding. In 2005, MSK Singapore was appointed as Meisei's first overseas distribution agent, and we set up a technical center to support customers outside Japan. After 79 years of operation, Meisei Kinzoku unfortunately ceased its operations in Japan in 2013, but we retained the technology. So between 2013 and 2015, MSK Singapore retained the mini runner system technology and continued advancing it. In 2015, we also began designing and manufacturing our palletizer machines here in Singapore, adding a second pillar to our product line. And from 2020 onward, with our offices in Thailand, Japan, and our global distributor network, we now support customers in over 20 countries. Here you can see some of the countries where we support customers today. Across Asia, Europe, and the Americas, we have appointed distributors who are well-versed with our products. We understand that molding challenges are often very application-specific, and that our customers need more than just the equipment. So our global support network provides practical support from inquiry to testing, installation, and even maintenance. Wherever you are, there's a good chance we already have a partner who can assist you. Today, I will focus on our two core products. The first is the Mini Runner System, a high-yield injection molding technology designed to reduce runner waste and improve productivity. The second is the air-cooled palletizer, an eco-efficient thermoplastic recycling technology designed to turn runners and regrind into more consistent repelletized material. Together, these products address two sides of the same customer goal: use less, waste less, and produce more consistently. In this diagram, you can see how both our core products fit nicely into an eco-efficient process. It starts at the top, your injection molding machine fitted with our mini runner system. Right away, you're producing parts with far less runner waste than a conventional cold runner setup. Whatever runner you do produce goes into the crusher, then through a dehumidifying dryer to remove moisture. From there, the dried regrind goes into our air-cooled palletizer, which turns it back into clean, uniform pellets, the same size as virgin material, ready to feed back into your molding machine. So instead of paying for waste twice, once when you buy the resin and again when you dispose of the scrap, you close the loop. You can produce less waste at the source with our mini runner system, and you can reuse what you do produce with the help of our palletizer machine. So here is an example of that closed-loop system in action. Two common uses of repelletized materials are, number one, mixing 30 to 50% of repelletized material with virgin material to produce the same original product, or number two, using the repelletized material to produce a second product. This is an example of the latter. So this customer of ours is a contact lens manufacturer, and they produce blister packs from PP homopolymer, and the runner waste from that production used to simply be waste, about 2 tons a week or 8 tons a month. With our process, instead of throwing that material away, they recycle the runners and use the repelletized material to produce the contact lens casing, a second finished product that they sell. So same factory, same material, but now their runner waste becomes a second product. In the rest of this presentation, I will be diving deeper into our two core products. So let's begin with the mini runner system. This is MSK's high-yield injection molding technology for customers who want to reduce runner weight while maintaining a practical and economical mold structure. Before we get into how it works, I want you to see the range of applications. Every system you see here is one we've designed and built for a real customer. Whether it's a small 2-nozzle 8-cavity setup, a 30-nozzle 120-cavity system, or a 2K or 2-shot mold, the mini runner system scales to your needs. There are 4 key benefits of using our mini runner system. Firstly, it saves raw material by reducing runner weight. Less plastic disappearing into runners means lower material cost on every shot. We'll see exact numbers in the case studies in a moment. Now, secondly, it achieves higher productivity through 4 mechanisms working together: reduced cycle time, reduced idling time, reduced energy consumption, and reduced machine downtime. Thirdly, it improves consistency of product quality because the resin enters every cavity at a uniform temperature. And lastly, we offer the smallest nozzle pitching on the market, with a minimum pitch of only 19 to 20 millimeters. That means we can pack more cavities into the same mold base than almost anyone else, which directly translates to a higher output per machine. In simple terms, less waste, more parts per hour, better quality. So this is one of the clearest ways to picture the impact. On the left, you can see the runner system from a conventional 32-cavity cold runner mold. On the right, the same job after converting to our mini runner system. The volume of runner material has been reduced by 89%, and cycle time has been reduced by 30%, meaning the same machine in the same shift produces significantly more parts. So you're saving on material and gaining capacity at the same time. And I will now show you a video of the same case. So in this video, you will see how we help this customer achieve a 530% increase in productivity. After the conversion to the mini runner, as you've seen in the previous slide, we work closely with them to increase from a 32 cavity mold to 80 cavities and eventually 120 cavities, all whilst using the same injection molding machine. Please take a look. So as you can see, these are real customers, real machines, and real numbers being delivered on the production floor every day. Let's now look at a second case study that breaks down the material and cycle time savings in more detail. So this is a real customer case. The product was molded in POM at a material cost of roughly $4 per kilogram with a monthly volume of 580,000 parts on an 8-cavity mold. When they converted from a cold runner to our mini runner system, runner weight dropped from 27.42 grams per shot to just 4 grams, a saving of 85.4% of the runner material on every single shot. That translated into monthly material consumption. They went from nearly 2,000 kilograms of runner material a month down to just 290 kilograms. That's a direct saving of almost 1,700 kilograms of POM every month, which is about 6,800 US dollars every month on this one mold alone. And the cycle time came down from 32 seconds to just 24 seconds, a 25% reduction. So in the same month, on the same machine, the customer produced 662,000 parts instead of 496,000. That's an extra 166,000 parts per month from one machine. So let me tell you a bit more about our technology that made this possible. First, we use a heat transfer method. The heater is placed only on the manifold itself, not on every nozzle. This makes the system simpler, more compact, and easier to maintain. Second, we use a special combination of materials inside the manifold and nozzles to ensure that the temperature flows uniformly all the way to the gate tip. This is what makes the heat transfer method work reliably. Third, because the heat is so well distributed, you only need a single or double zone temperature controller for the whole system, and we guarantee a temperature difference within 5 degrees Celsius across the entire manifold. That's what gives you consistent fill and consistent part quality. Compared to a conventional hot runner where every nozzle needs its own heater and its own controller, this is a much simpler, more economical, and more reliable approach. To summarize the Mini Runner's key features, it's a simple and compact design which makes it easy to integrate into existing tools. Conversion of your current molds to the Mini Runner system is straightforward, which I'll show you in the next 2 slides. It's the most economical system on the market, particularly suited for products with smaller pitches between cavities. Each system contains a manifold with a built-in heater, sprue bush, and nozzles, all engineered to work together as one unit. And maintenance is easy. General in-house cleaning takes only 2 to 3 hours. Even a full overhaul for severe cases takes 2 to 3 days. So you're not looking at extended downtime to keep the system running well. Okay, so many of our customers ask, how do I actually convert my existing mold? On the left, here's a typical 2-plate cold runner mold. You can see the runner system in red. And on the right, the same mold after conversion. The mini runner system sits cleanly inside the existing mold base, and the runner is reduced. The photo below shows the actual molded shots. Far less waste material around each part with the mini runner system. So your existing tooling investment is preserved. The same conversion logic applies to 3-plate molds. So the diagram on the left shows where the mini runner system integrates. The manifold sits within the existing plate structure with the cartridge heater, sprue runner, and bushing holder all in standard positions. And on the right, once again, the visual difference. The cold runner system at the top produces a substantial runner skeleton, whereas the mini runner system at the bottom produces only the parts and a few small gate stubs. So you get the same productivity but far less waste. And just to give you a bit of confidence on the practical side, here's a short video taken at one of our customer sites showing how they assembled the mini runner system.
So it's a simple process. We're happy to guide your team on this, so once installed, your in-house engineers can handle routine assembly and maintenance themselves.
If you'd like us to look at one of your molds, here's what we typically need from you. So for a preliminary inquiry, just enough for us to assess feasibility, we'll need the cavity half in 3D format, ideally STP or Parasolid, the resin specification of the product, the number of cavities and drops, and whether this is for a new mold fabrication or modification of an existing tool. When you're ready for a formal code, we'll need a little bit more, so a preliminary mold design showing the drop pitch, the slider design if any, and the gate type, the number of cavities and drops, and whether it's a 2-plate or 3-plate mold. Once we have these, our engineering team can come back to you quickly with a tailored proposal. Now let's move on to our second core product, the air-cooled pelletizer. This is our eco-efficient thermoplastic recycling technology. If the mini runner system helps you produce less waste, the pelletizer helps you turn the waste you do produce back into something valuable. We offer 5 models in our pelletizer range, all CE certified for the 380-volt versions. From left to right, you'll see the double hit models RP32DE, RP32DD, and RP32EE. And then our compact single hit models, the RP32D and RP32E. So the D in the model name stands for direct module, and the E stands for extended module. So for example, a DE has 1 direct hit and 1 extended hit, and we'll explain what that means in the next 2 slides. So here's how the direct module works. Step 1, your regrind material is loaded into the hopper at the top. Step 2, it goes into the heating extrusion chamber where it's softened below molding melt temperature. Step 3, it passes through air cooling. Step 4, the cooled material is cut into uniform pellets by our cutter. And step 5, the finished pellets are output ready to feed back into your injection machine. So this direct module is ideal for materials that cool quickly and don't require a long cooling stage. So the extended module follows the same overall flow but with one key addition, an extended cooling stage between the air cooling and the cutting, right over here. So for certain materials that need more time to solidify properly, the extra cooling step ensures you get clean uniform pellets. So here's a video so you can better see the extended module's process flow. So when we recommend a machine for you, we look at the specific resins you're recycling and we match the right module to your materials, whether it's direct, extended, or a combination. So I would like to begin by answering the question, why bother repelletizing? Why not just crush the runner and put it straight back into the machine? Well, there are 4 very good reasons. First, repelletized material can be made the same size as your virgin pellets, which means even mixing of virgin and recycled material in your hopper. Crushed regrind comes in irregular flakes that don't blend evenly. Second, crushed material typically stays behind virgin material when entering the screw because of its different shape and density. So the result is inconsistent feeding and inconsistent part quality. Third, residue from crushed material is often overheated inside the machine screw because the irregular shapes don't melt at the same rate. This can cause carbonization, which is those black specks you see in finished parts. And fourth, repelletized material is justifiable for a higher UL regrind percentage. For customers in regulated industries, this matters a lot because you can demonstrate that your recycled content is qualified material, not just crushed scrap. So repelletizing isn't an extra step, it's the step that makes recycled material useful. So 6 key features make our pelletizer different. Number 1, environmentally friendly air cooling. No water, no water treatment system, no wastewater. That's a major operational and environmental advantage over conventional water-cooled pelletizers. Number 2, we process below the molding melt temperature. This is important. It means that the material's properties are largely unchanged when repelletized and harmful fumes are reduced. Number 3, a simple, compact design that supports unmanned operations. Once it's properly set up, you can run this machine without a dedicated operator. Number 4, an easy-to-use touchscreen control panel for both operations and troubleshooting. Number 5, customizable pellet size. Pellet diameters from 1 to 3 millimeters, lengths from 1.5 to 5 millimeters. You can tune it to match your existing virgin pellets. And finally, outputs of 5 to 10 kilograms per head per hour, depending on various factors such as the material, pellet size, and machine settings. On a double head model, that's up to 20 kilograms an hour. Here is a real example with 30% glass fiber reinforced LCP. As you can see, our pelletizer machine turns recycled material into uniform pellets, even with a fiber-reinforced engineering resin, and we only use air cooling and process below molding melt temperature. And we've done this with a wide range of resins. On this slide, you can see that we have extensive experience with repelletizing various resins, covering commodity resins like ABS and PP, engineering thermoplastics like PC, PBT, and PE elastomers, and high-performance materials including LCP with glass fiber, PA90, PA10T, PA40, most of these with significant glass fiber content. In other words, if you're working with a thermoplastic, there's a very good chance we've already pelletized something similar, and we can replicate that result for you. If you would like to watch any of these case study videos, you can scan the QR code on the slide or find us on YouTube under MSK channel. Moving on, this is a quick note on what you need to install one of our pelletizers. So for power supply, our machines come in 2 electrical configurations, so you can choose between 200 volts at 50 amps 3-phase or 380 to 415 volts at 30 amps 3-phase plus neutral, whichever matches your needs. For air compressor supply, you will need 6 bars or higher. And depending on the resin, you may want pre-drying through a dehumidifier before pelletizing. For some materials, it's not strictly required, but it ensures optimal pellet quality. In terms of energy consumption, for reference, our RP32DE, running both nozzles simultaneously at typical engineering settings of 350 degrees Celsius barrel temperature, screw and cutter speed at 85%, and roller speed at 50%, draws around 2.6 kilowatt hours. So if you're interested in our pelletizer machine, do get in contact with us and we will recommend the right machine model for you. All we need to know is the recycled materials you'll be running, including whether it has any additives or glass fiber content, and the material maker and grade if you have it, your estimated monthly or yearly usage, and what the parts are used for, whether that's automotive, medical, consumer products, or something else. And that brings us to the end. So to quickly recap what we covered today, firstly, the mini runner system. It helps you make less waste at the source, saving on material and lifting your output, whereas the air-cooled pelletizer helps you turn the waste that you do produce back into high-quality pellets. Together, They form an eco-efficient process that lowers your cost per part while supporting your sustainability goals. So if you'd like to learn more, you can find our company profile and case study videos on YouTube under MSK channel, or you can visit our website at www.mskpl.co, or you can simply email us at sales@mskpl.co. Thank you for spending these 25 minutes with me. We would love to answer any questions or inquiries you may have about our products. So I look forward to hearing from you soon, and thank you again.